Welcome to the Road to Accountable AI. I'm Kevin Werbach, Professor of Legal Studies and Business Ethics at the Wharton School of the University of Pennsylvania. For decades, I've studied emerging technologies from broadband to blockchain. Today, artificial intelligence promises to transform our world. But AI won't reach its potential without accountability, mechanisms to ensure it's deployed in responsible, safe, and trustworthy ways. On this podcast, I speak with the experts leading the charge for accountable AI. Whether to restrict open-weight foundation models is a big topic of discussion in AI safety and policy circles, but not one that the general public and business community are necessarily focused on. My guest, Kevin Bankston from the Center for Democracy and Technology, talks about why this issue is so important, both to the future of innovation in AI and to our ability to address serious AI risks. As you'll hear, Kevin has strong views, and in full disclosure, I signed on to an open letter that CDT wrote on these issues. But in our conversation, we cover the arguments on both sides of the issue and why this topic is actually so important to understanding what the future path holds for the development of AI. Kevin, pleasure to have you on the podcast. Before we get into talking about open weight models, just tell us a little bit about your background, and for those who aren't familiar, what CDT is. What's the work that the organization is doing on AI?
Sure. I'll start with CDT. CDT is, I would say, the premier internet and technology policy think tank and advocacy organization in DC. We've been around for, I want to say, almost 30 years at this point. Nonpartisan, nonprofit, focused on protecting civil rights and civil liberties in the digital world. That encompasses a whole lot of things. It's a broad spectrum organization, but obviously right now AI is at the forefront of a lot of technology policy discussions. And I, with my colleague Miranda Bogan, co-founded the new AI Governance Lab at CDT, which is focused on helping develop best practices and standards around evaluating and mitigating AI risks to help build a technically informed basis for eventual legislation and regulation, taking advantage of not only my 20-odd years in civil society at organizations like and including CDT. After that 20-odd years, I was approached by Facebook, now Meta, to basically help them figure out their path forward on responsible AI development, which was an intriguing possibility. And so I spent about 4 years building their AI policy team, being one of the founding senior leaders of their responsible AI product team, which consults with all the other product teams on their AI products, and did a lot of good work. But obviously, working in a big company like that in a lot of ways is very stressful and challenging and time consuming. And I am at this point, a late middle-aged fella who more accurately, my wife just had a baby. And I decided, for a variety of reasons, but especially including that one, I was ready to leave the corporate world and come back to civil society and apply what I had learned, and also what Miranda, as my colleague on my team at Meta, had learned around responsible AI development. So now Miranda, who did trailblazing, groundbreaking work at Meta in terms of addressing issues of race and gender bias in ads delivery, she is the director of the new governance project at CDT, while I'm a senior advisor to that project and to the leadership at CDT on other AI policy issues. I currently teach the First Amendment and copyright in regard to AI technology as an adjunct professor at Georgetown. Those are issues that CDT has not spoken greatly about. We do address the First Amendment in regard to this issue a little bit in the comments we're going to be talking about. But speaking generally, if I talk about the First Amendment here, attribute that to me as Kevin the scholar, not necessarily CDT's positions.
Great. So this is why you are a perfect person to talk about these issues. I want to ask you in particular about the debate that's happening now around open weight foundation models. So first, for those who aren't necessarily familiar, what are we talking about here?
So this will require a little bit of a history lesson about what open source software is before we get to what open source AI is. So in the 90s, you began to see the evolution of this new form of software development and licensing around this open source concept, where you would have companies or even voluntary projects with a bunch of contributors developing their code openly, as in collaboratively, or when publishing their programs, also publishing the source code itself so that other people could use that to build their own software, to modify it for their own uses, et cetera, et cetera. Usually this is accomplished through something called an open source license, which basically says you can use this and there are no use restrictions on it. We are essentially, although we still own the copyright in this technically, we are licensing it broadly for public use. So why is this important and, speaking generally, good? Certainly the internet and digital technologies built around and on the internet rely an enormous amount on open source software. At this point, 96% of all code bases include some open source code. It's the original open sourcing of the Netscape browser in the 90s, which led to the open source Mozilla Firefox browser, which was a predecessor to later the Google Chrome open source browser that enabled competition so that we didn't all just have to use Microsoft Explorer on the web. Now, I want to be clear, open source is not and will not be always a silver bullet for competition, and it can be leveraged by already powerful stakeholders to make them more powerful. Certainly, it's enhanced Google's structural power, the fact that it controls ultimately the development of Android, for example. But then again, that power has also helped counterbalance the power of other people, other companies like your Microsofts and your Apples, and enabled a large number of hardware vendors to compete that wouldn't have had an operating system to use. And it's a complicated ecosystem, but ultimately, open source in the context of regular software has been a boon for competitiveness, also a boon for security. In the world of open source, they say enough eyeballs make all bugs shallow. This is because if you have your source code interrogable by anyone, that means you have a lot of eyes looking at it and finding flaws and helping you patch those flaws. That's why, for example, the security world has generally been supportive of the open sourcing and wide availability of penetration tools for breaking into computer systems, not because they want to help people break into systems, but because they want to help people detect how to break into systems so they can fix those things. And so speaking generally, open source has also been a boon for our overall technical security. Now we have to get to AI, though. And open source is a little bit of a misnomer when talking about AI for reasons I'll get to. First, I'll have to back up and say, what are we talking about when we're talking about AI? Very generally, when we're talking about AI, we're talking about machine learning, which is using software to look at vast amounts of data to find patterns in it that are useful to us. In the current context, we are usually talking about large language models or other generative models. And to break that down as simply as possible and get to answering the question of what are weights, I'll just say, to make a large language model, you take a whole lot of data, often everything you can scrape from the web, data you've licensed from other vendors.
A large amount of language, right?
A large amount of language, and feed it through an algorithm that creates what is essentially a massive mathematical space that sort of summarizes all that data, not directly, but rather not even each word, each part of a word, and they're called tokens in this context, gets its own little spot in this sort of semantic map of all of that content. So that, for example, as it has ingested more and more data, it begins to not understand, but be able to place close to each other related semantic concepts like dog and puppy, for example, are close together in this map. What happens then is, once you've trained that model to create that mathematical map, which is what we call weights, because to put it in non-technical language, like all of that semantic content has been weighted to some extent or another in this mathematical model. You need the weights to be able to infer anything for the model to actually give you an output. Open weights. And so now the analogy to open source comes in. There, as with regular software, there's both open and closed approaches. The closed approach is, for most of its models, a good example is OpenAI and the way it treats most of its most powerful models, which is it is available through them. You have to either go to their website and pay the $20 to access their user interface for chatting with ChatGPT, or you're a developer who pays to access their API, their application programming interface, to build apps or services, internal or external, on top of their model. Either way, though, they have centralized control over the model. Users and developers do not have direct access to the weights. And yeah, so that's closed AI. Open weights AI, and I hesitate to call it open source for reasons I'll explain, is when you publish, at the very least, the model software and the weights so that another developer could deploy that on their own infrastructure with their own modifications. So in many ways, it is similar to open source software because these open weights models are typically offered under a license that either that allow for free redistribution and or don't have use restrictions and or otherwise give you freedom to play with the model and build derivative models in a way that you can't do with a closed model. I don't call that open source for a few reasons. One, most of the components of the model are not in the form of source code. And in fact, this critical heart of the model, the weights, is not really interpretable by a human at all. But I also don't call it open source automatically because it depends on the license. Speaking generally, an open source license is one that does not have use restrictions on it. And yet, as we'll talk later, there are emerging some new kinds of licenses that, for AI safety reasons, do actually attempt to restrict the allowable uses for a model.
Okay, so let's get into the policy issues. This sounds companies can decide open, close, as they do with software. What's the concern?
There are a number of concerns, but I'd love to start with the benefits, because really the policy question requires us to weigh the benefits and the risks. And I think the benefits, although there are some ways that open source software and open weights AI are not identical, there are a lot of ways that they are similar, particularly in their benefits. And I break these benefits down into three basic categories. One is simply distributing power, whether in the market or in the culture, which I'll explain. Basically, as with open source software, we expect and we currently see open weights AI being a strong competitive pressure against closed providers, not least because it is free. We are seeing very fast diffusion of the technology. We see very large enterprises adopting it, including for internal uses like Dell and Wells Fargo. There's a great quote from a Dell senior VP that's basically like, why would we pay for a general purpose model that does not know much about our company? And if we want to teach it that, we have to upload all of our private documents to their cloud and we have to pay for it. Or we could use this free software and create our own bespoke model for our own purposes that is more efficient, more tailored to our needs, et cetera, et cetera. And so you're seeing that. The second big category of benefits is simply the catalyzing of innovation, not only innovation in AI, but in all fields that can leverage the AI. The first LLMs that were built were open research. They were openly published. The Google research scientists who created the first LLMs in 2017-ish. That is the root of the explosion of AI innovation today, is the fact that research happened in the open. Thanks to open development, you also see an explosion of developers taking open models and then using them to build smaller, more efficient, customized models, build models that are small enough to run locally rather than in the cloud, which has both privacy benefits and environmental impact benefits, and just bandwidth benefits. Like, you don't have to spend all that network infrastructure. Research around AI models also enables a wide swath of security and safety research that can't happen effectively with closed models, and can enable the faster development of, including the faster development of tools to detect and prevent bad things. There's another way in which it can help security rather than hinder it. And then all the other fields that leverage this AI, they will also move faster. And so there is a benefit of simply speeding up the process of innovation and opening that process to a lot more stakeholders as well. And then finally, there's the transparency benefits, which also bring security and accountability benefits. Like with regular open source software, with enough eyeballs, a lot of those problems will be discovered and can be remedied because the whole world essentially is your red team, the team that's testing it. There's a lot of research that's happened that couldn't have happened without open source models around guardrails, the guardrails that companies use to try to prevent bad things from happening with their models. A lot of the challenges with those guardrails have been discovered through open source models, developed in a way that actually reflects on the flaws of the closed models as well. Because they're similar architectures, the closed and the open models, things that you learn about open models can be applied in your thinking about closed models as well. So it's a way of even getting more transparency into the closed models, even though we don't actually have literal transparency into the closed models. And it's enabled research around bias and discrimination that wouldn't have been possible without access to the model and the weights. And one of the things we've discovered in all that testing is, and this is problematic and worrisome, but also relevant to the analysis of whether open source is worth the risks considering the benefits, is the guardrails that we are currently using to try to basically say no, have a model say no to you when you try to do something dangerous or problematic. Those are very fragile. And they're fragile whether or not you are using open or closed models. And we wouldn't have known that without research that was enabled by open models. This goes to an important concept that we'll need to talk about when we talk about the risks, which is what is the marginal risk of open source or open weights models compared to other technologies that are available, whether it's the internet itself or closed models that are also available to be used. Because if there's not a if there's not a meaningful marginal risk, that is differential risk between those two things, there's no reason to target open source specifically for restriction. And we should probably think about a different approach.
Okay, sounds wonderful. Why then are there concerns? Let me ask you in a more targeted way. NTIA, National Telecommunications and Information Administration, and the Commerce Department launched this request for comment in early 2024 about open weights models. Why did the government feel the need to even ask whether these should be allowed to exist in a free form?
Yeah, I think there are a number of different categories of risk and a number of different phases of concern that we've gone through at this point in the past 2 years since ChatGPT dropped for real. I'd say the first category I would call emergent existential risks. I would say these were very much at the forefront of initial thinking about the dangers of AI because there is a community, we'll call them the AI safety community, although there are plenty of other different types of AI safety folks and stakeholders. There is a community around AI safety that essentially evolved over 20 years from work being done in the Oxford Philosophy Department around potential existential risks that humanity might face. And one of those, these people have theorized for a while now, is the possibility of some out of control, super intelligent AI that we lose control of and that does something catastrophic to harm humans for its own reasons or because it misunderstood its instructions. And I don't want to denigrate the people who are raising this concern. Speaking generally, I think these are very intelligent, very well-intentioned, sincere people who want to see these concerns addressed and don't want to see AI destroy the world. Nor do I. The more likely threat than the sort of vague super AI is the possibility that these systems, as they get more intelligent, could significantly aid adversaries, whether state adversaries or non-state adversaries, in developing chemical, biological, radiological, or nuclear weapons, or cyber weapons, hacking tools and whatnot, and automated attack approaches. We will talk at more length about that because it ties in to the NTIA process. But really the key issue there, as is the key issue generally, is there actually a marginal risk? Does open source pose a greater risk of those things than other technologies? And I'm not going to spoil that. I'll tell you how that turned out. A third category is simply content, issues of harmful or problematic or illegal content, particularly of concern, are deep-faked child sexual abuse material, virtual CSAM, or deep-faked NCII, non-consensual intimate imagery, often called revenge porn. And this is going to be a problem and is a problem. But again, the marginal risk issue is a question that needs to be asked, and we'll ask it shortly. But finally, the fourth category, and where I think most of the concern is settling now, and which I'm sure we'll talk about later, is China. China specifically. What do we do about Chinese competition in the AI field? How do we deal with China as a national security competitor in regard to AI as well? And I think we are at a point now where that's probably the most relevant consideration for policymakers in the US as they look toward possible restrictions on open source now. But so that's the sort of range of risks I think people are most concerned about.
Okay, let's drill down on some of those. I agree we can put aside the existential risk, but with regard to marginal risk, you made the point that guardrails on these foundation models are fragile. But isn't it true that it's substantially easier to remove a guardrail if you have access to the weight? So if it's an open model, then it's fairly trivial for someone that's a hostile actor to take out those guardrails. Much more challenging if the company keeps control over the model.
It depends. You may have seen OpenAI's latest model release last week, and then within minutes on Twitter, people sharing their attacks, their prompts that were able to get around certain content guardrails. The Taylor Swift sexually explicit deepfakes that we saw making the rounds earlier in the summer, those were generated by Microsoft's closed image creator. But yes, open source models are more easily modifiable in a wide range of ways, including by bad actors. But then that leads to the question of what about other technologies? How does it compare to those? And that's something that the NTIA got into. But to set up the NTIA process a little bit and back up, this came up in the context of the Biden AI executive order that came out October 30th, I want to say, last year, and which called on NTIA to do a report on open weights AI. This was prompted, as best we can tell, by there being staff at the National Security Council of the White House and staff at the Bureau of Industry and Security, the export control guys at the Commerce Department, who were concerned particularly about the CBRN and cyber risks and China, and were considering the possibility or looking at the possibility of putting restrictions on the publication of open weights because of those national security concerns. It seems that somewhat cooler heads prevailed in instead pushing for that not to be decided in the EO, but rather to delegate to NTIA, the National Telecommunications Information Administration, essentially the president's the president's technology advisors, to do a more sustained study of the issue in particular being, what are the benefits of open weights models? What are the risks of open weights models? And based on that, what are potential policy approaches the president should take or not? And so that was the process. And they put out the call for comment earlier this year. A bunch of people filed comments, including us, and I'll talk about that. And then they finally released a report, I guess, a couple of months ago. And so let's talk about that. And I'll talk about the comments that CDT filed. First, a not so humble brag, I'm proud to say, this is a dubious achievement, but our comments were the longest and most detailed comments filed in the proceeding, which had hundreds upon hundreds of comments. More salient, our comments were cited in the report from the NTIA more than any other comments. And the only other single source that was cited more than our comments was a paper that we co-authored with academics at Stanford and Princeton focused on defining marginal risk around open models. And I'm glad to say I feel that we had a very positive influence on this process. We also worked closely with NTIA to ensure they heard from a variety of other civil society voices, from civil rights groups to civil liberties groups to open source advocates and everything in between. But the gist of what we were saying in the paper I mentioned, in our comments, is we are not ruling out categorically the possibility that some restrictions on open weights may ultimately be necessary. But at this point, with the capabilities we see online now and that are coming shortly, there is not enough evidence to support those restrictions. And by that, not enough evidence that there's actually a significant marginal risk from open models. This is probably clearest in the context of the biological and nuclear and cyber conversation. There, by the time of our comments, there had been several academic papers and papers from security think tanks like RAND, research by Microsoft and OpenAI research, where they basically set up teams to compete on who could come up with the best evil terrorist plan around biological weapons, and gave one team access to the best models and one team access to the internet. And what they found was there was very little difference in the capacity of those teams to plan an attack, which stands to reason because what the models know is what they've seen online. And so it may give some incremental additional aid in collecting some of your sources when you're looking for information to help plot a plot, but it really didn't make a huge difference. Similarly, there was research on how much models, which certain models can also help, instead of just speaking in language, they can also code, they can create software. And so there were tests about how effective they were in helping create penetration tools and other attack tools. And again, they found only a incremental difference, not really a major difference, between what a coder could do without a model and what a coder could do with a model in terms of offensive cyber stuff. It's also worth noting, as with the case with open source software, that capability to create tools also is now in the hands of defenders as well as attackers. And as we've seen in the open source context, that has tended to ultimately benefit defenders more than attackers. And so NTIA, which was primarily focused on those as the most realistic national security related threats that they were asked to assess, essentially concluded, we don't see a significant marginal risk here. That doesn't mean there might not be one at some point. Therefore, we do endorse continued monitoring. I guess what a doctor would call watchful waiting. It's not something that requires intervention now, but something that we need to be watching closely, including recommending continued investment in the development of best practices and standards around safety, as well as market surveillance and other measures to see how these models are being used, because so much of the risk is actually going to turn on what contexts it is being used and by what types of users, and basically advise the president to hold off on restrictive measures. And I think this was the right decision in a number of ways, but especially by analogy to a similar fight over tech policy that we had in the 90s that we haven't talked about yet, but that has to be talked about in this context, which is the fight over open source encryption code in the 90s and early 2000s. I think we have a very similar issue with AI today. And this is, now I'll talk about China, because it's a very similar situation where in the encryption case, it was, we are afraid our adversaries will misuse this technology. And therefore, we want to try to limit the spread of this technology. But the technology we're talking about is literally bits. It's not a physical thing that we can physically constrain. And so it's really hard to prevent the spread of software on a global internet. And that's as true today, if not more than it was then. And there are those that are concerned that if we are doing open source AI models, that we are giving away our IP to our competitors in China, that we are giving away software that could be integrated into military operations by China. Both of those are true in the sense that certainly there will be stakeholders in China that make use of this software. But even if our software is not available, they will make use of similar software, whether it comes from France or the United Arab Emirates or China itself, where there are plenty of large models being created today without reliance on US technology. So I think it's a question of, yes, we could attempt to restrict this. We would probably fail. It would probably leak anyway. But even if we did not fail, it likely wouldn't be effective in preventing China from getting comparable technology elsewhere. Meanwhile, we will have slowed down our own innovation cycle, slowed down the diffusion of the technology generally and the many economic benefits and other benefits that will accrue from that, and have hindered our ability to compete in the global marketplace around this kind of software, which I think is especially important to consider when you think about China's geopolitical position right now and things like the Belt and Road Initiative, which is its massive global attempt to provide infrastructure, including communications infrastructure, to the global south, to Africa, to South America, to the Middle East as a way of consolidating geopolitical power. Our having a robust open ecosystem of AI models is probably our best shot at preventing China from dominating the AI market in those global markets. And they're actually at a unique disadvantage compared to our open models because they are China. The CCP has already passed regulations that basically enforce ideological purity on Chinese models, basically censorship in line with the party line in China, which makes them necessarily much less useful to a lot of stakeholders. So if we can compete on a global stage with free, powerful, customizable AI software, and China is competing with less good software, then that actually strengthens our geopolitical position in regard to China rather than weakening it, would be our argument. And the argument at this point of a number of relatively conservative stakeholders as well as your center-left types like me.
Okay, there's a lot more that I would love to get into this with you about, but we have limited time, and I want to just ask one or two more questions.
Sure.
One is that the company you used to work for, Meta, is the only one of the major frontier AI labs that seems to be pushing forward with releasing its most powerful models, the Llama models, as open weights. So can you, understanding, of course, you are not speaking for them, can you talk a little bit about maybe why it seems like they've taken that direction, and how is that going to affect this debate that it's not now just an issue about AI safety, but it plays into all of the competitive and other debates in the technology industry?
Sure. Yeah, I'm not going to attempt to divine the mind of Mark Zuckerberg or say anything confidential that I may or may not have learned inside of Meta, but I can note some things that other people have said and some obvious facts. I think one of them is the simple fact that Facebook, now Meta, doesn't have a cloud services division through which it wants to sell access to closed models. Its whole business model is different. It offers consumer products to consumers that rely on AI, but them dominating the AI model market is not their goal, as one could argue is the goal of your Googles, your Microsofts, your Amazons, your OpenAIs. So they just have different incentives. One of those incentives is by opening their largest model, which is also, they've said, the model that is going to be the primary basis of a lot of features in their products, they can get the traditional benefits of open development. They can get those millions of eyes on their model. They can benefit from seeing what customizations people are doing on platforms like GitHub or Hugging Face and integrating the good ones into their production model. And then there's also simply, finally, the obvious fact that it is what Meta, when ChatGPT dropped, Meta had long been doing open source releases of research models. Some may recall the dubious release of Galactica shortly before ChatGPT, which was an LLM trained on and focused on scientific literature that spouted nonsense and was taken down pretty quickly. And so you already had this large research investment in developing LLM technology that wasn't necessarily being productized. And there's the obvious fact that if Meta threw that out there while OpenAI and Microsoft were trying to consolidate a closed AI position, it would slow down those competitors. Many of your listeners may have heard of the memo inside of Google. I believe it was called OpenAI has no moat, and neither do we, in the sense of a competitive moat against open source. And I think people inside of Facebook probably followed a similar logic. I'm neither confirming or denying. And in fact, I was on parental leave for much of this decision making, but recognized that offering this would not only create a lot of benefit and use for a lot of people, but also slow the adoption of closed models offered by their competitors who, again, Meta doesn't offer a cloud service, but it does offer a lot of other services that are in competition with a lot of these companies. And so I think, as a number of commentators have noted, that was a clear benefit to Facebook if they could throw an obstacle in front of their fast-moving opponents in the market. As I make the distinction between open weights and open source, Meta is a good example of why we need to be really careful about our terminology there, because Mark Zuckerberg loves to call Llama open source and use that terminology, but the license that Meta is licensing under is definitely not an open source license. In some ways that are arguably good and in some ways that are arguably bad. Most notably, their original license forbade you from building a model using outputs from their model, which is actually a very powerful way of building smaller, more condensed versions of models. Thankfully, they fixed that, but now if you do that, your model has to be marked as built with Llama. And you don't typically see that kind of branding requirement in the open source community. And so I'd love for them to get rid of that. And then also, as has been much commented on, they also have a clause that prohibits any company with more than 700 million average monthly users to use the model. This is to basically prevent Google and Microsoft from using the model for free. And if they want to use it, they'll have to go to Meta to license it. Again, like, that's not the sort of thing you'd see in a regular open source license, carving out particular users. At least it is limited to companies that had that level of users at the time of the license. So it's not like you could build your company on Llama, ultimately get to 750, and then suddenly have the bottom pulled out of your business. But it's still fair to say not anti-competitive, and something that especially if they want to keep calling it open source, they need to take out of their license, or they need to stop calling it open source.
All right, there's a lot more that we could talk about here. Obviously, the NTIA report will not be the last word, but we're going to need to wrap up for time. Kevin, thank you so much for going through in so much detail this really important set of issues with us.
Anytime. It was a pleasure.
Great to have you. This has been The Road to Accountable AI. If you like what you're hearing, please give us a good review and check out my Substack for more insights on AI accountability. Thank you for listening. This is Kevin Werbach. If you want to go deeper on AI governance, trust, and responsibility with me and other distinguished faculty of the world's top business school, sign up for the next cohort of Wharton's Strategies for Accountable AI online executive education program, featuring live interaction with faculty, expert interviews, and custom-designed asynchronous content. Join fellow business leaders to learn valuable skills you can put to work in your organization. Visit execed.wharton.upenn.edu/ACAI for full details. I hope to see you there.